So if you sit down right now and try to count to 1,000,000, just doing like one number per second, it's going to take you about 11 and a half days.
Yeah, which is, I mean, it's a tedious project, but you can kind of wrap your head around it.
Right, exactly. But if you decide to keep going and count to 1,000,000,000, you would be counting continuously for 31 years.
That's a literal lifetime of effort.
Yeah.
Just counting.
Yeah, and here's where the math just totally breaks human intuition. If you try to count to 1,000,000,000,000, 1 second at a time, it takes 31,700 years.
Which is just, we are not wired to process numbers that large. We just aren't.
We really aren't.
Yep.
So, when we talk about a billion-dollar company like a unicorn, we're talking about something massive.
Right.
But when we start throwing around the term trillion-dollar company, we have completely left the realm of normal business metrics.
Absolutely. I mean, at that point, you're no longer talking about a company that operates within an economy. You're talking about an entity that practically becomes the economy itself.
Yeah, it forces this total recalibration of how we measure impact, doesn't it?
Oh, totally. A trillion-dollar entity functions way more like a sovereign state or like a foundational utility than a traditional corporation.
Which brings us to you, the person listening right now, because whether you're prepping for a massive strategy meeting or maybe you're an entrepreneur trying to figure out, where to place your bets.
Or maybe you're just incredibly curious about the underlying physics of the future economy.
Exactly. We are bringing you a custom-tailored deep dive today that tackles this exact scale. We've got this massive stack of notes, charts, and excerpts from a fascinating document.
Yeah, it's titled 1,000 Solaras in 10 Years by Paramendra Kumar Bhagat.
And the central thesis of this text is, honestly, it's incredibly aggressive.
It really is. The author isn't just suggesting we'll see a few more massive tech giants pop up.
Right.
The argument is that the convergence of artificial intelligence with several other exponential technologies is going to birth 1,000 individual trillion-dollar companies within the next 10 years.
1,000. And he calls these companies Solaras, right?
Yes, Solara.
And there's this visual motif woven through the source text that I think really anchors the whole concept.
Oh, the sun faces?
Yeah, sun faces. The author uses these images of vibrant, multicolored metal sun faces. So picture like overlapping plates of industrial metal stamped with these intricate geometric, almost tribal patterns.
And painted in these really vivid primary colors, right? Deep blues, harsh yellows, brilliant reds.
Exactly. And right in the center of these metal constructs are these highly expressive smiling faces that just look like they're radiating heat and energy.
And economically speaking, that metaphor is very precise. Because a traditional company, even a really successful one, is like a planet.
Right, it orbits something larger.
Exactly. It relies on the existing gravitational pull of the market. But a sun, a Solara, it generates its own gravity.
It fuses raw material to create its own energy.
Yes, and in doing so, it creates an entirely new solar system where other planets can exist. So a Solara is an economic engine that generates its own ecosystem.
Okay, let's unpack this. Because making the leap from our current tech landscape to a world with 1,000 trillion-dollar entities, that requires a massive bridge.
Oh, huge. Going from the unicorn era to the solar era isn't just about, software getting a little bit faster.
Right. The text argues this is about AI colliding with 11 other specific civilization-altering technologies.
But before we get to that trillion-dollar mark, the text really anchors us in the immediate reality.
Yeah, because to build a Solara, you first have to have a breeding ground for it.
And that breeding ground begins with just an absolute explosion of AI startups.
Right, let's talk about that explosion. Because the mechanics of how companies actually start has fundamentally inverted.
Totally. I mean, historically, if you wanted to launch a major technology platform, capital was your absolute biggest bottleneck.
You needed millions of dollars in venture funding just to buy the physical servers.
Exactly. Buy the servers, lease the office space, hire these huge layers of specialized engineers, product managers, HR staff.
You essentially had to build a small army before you even knew if your product actually worked.
Right. But looking at the math in the notes here, the argument is that intelligence itself has transitioned.
Yeah, from an expensive, rare human resource to basically an abundant, near-free commodity.
The text suggests that the work of a 50-person engineering and marketing team, operating over 2 years, can now be replicated by 3 people and an AI suite in a couple of months.
Which is wild. And when you remove the cost of failure like that, the volume of experimentation just skyrockets.
Oh, inevitably. If spinning up a new software company costs a few $1,000s instead of a few million.
And an AI agent is writing your back-end code, testing for bugs, generating your marketing copy.
Right, and handling the initial customer inquiries. I mean, the barrier to entry effectively drops to zero.
And to really illustrate this, the source material actually lists 100 specific AI startup ideas.
It kind of reads like a catalog of the near future, honestly.
It really does. And some of them are incredibly niche. Like, for instance, there's this one called an AI legacy code security assistant.
Oh, that one is so interesting.
Right. The way I read this, it's an AI that specifically reads through decades-old software languages.
Like COBOL, right.
Yeah.
Stuff running on old bank mainframes.
Exactly. It scans those ancient systems and identifies security vulnerabilities that modern engineers literally don't even know how to look for anymore.
Because nobody is learning COBOL in college right now.
Mm.
Another fascinating example from that list is the augmented reality shopping mirror.
Oh, yeah, the retail one. How does that work again?
So it uses computer vision to drastically alter the economics of retail returns. Because right now, returns are a huge friction point.
Multi-billion-dollar problem, easily.
Right. With this, you aren't just looking at a flat 2D image of a shirt on a website. The AI maps the actual fabric physics to your exact body dimensions in real time.
So you can see exactly how it drapes on you before you buy it?
Exactly, which slashes the return rate.
Wow. And the list gets even deeper into the hardware side, too. It mentions neuromorphic edge AI chips.
Yes.
Now, neuromorphic meaning these startups are physically designing silicon architecture to mimic the analog parallel firing structure of human brain neurons.
Right, rather than traditional binary zeros and ones.
And doing it at the edge, which means directly on the device, like your phone or a smart camera, so it doesn't have to send data all the way back to a cloud server just to think.
And that reduces latency to almost zero, which is absolutely critical for real-time applications.
Like autonomous vehicles.
Autonomous vehicles, robotic surgery, anything where a split-second delay is catastrophic.
Okay, so out of these 100 ideas, the text filters down to the 10 fastest paths to unicorn status.
The ones that can sprint to $1 billion valuation the fastest?
Yeah, and one that really caught my eye was the generative storytelling platform for children.
That one is a perfect example of flipping a legacy model.
Because traditional publishing relies on massive scale, right? Printing 1 million copies of one generic book. But this platform flips the model completely.
The AI basically acts as a real-time author and illustrator, creating a one-to-one personalized story.
So, like, if your child is struggling with fractions but absolutely loves space exploration,
the AI generates a dynamically adjusting, beautifully illustrated narrative where your child is literally an astronaut using fractions to calculate fuel trajectories on Mars.
that is so cool, and it adapts as they read.
Yeah, it learns the child's reading level, adjusts the vocabulary density page by page, and incorporates their specific behavioral interests.
Amazing. There's also an AI-driven legal contract generator mentioned in that top 10.
Right.
The premise there is that instead of a small business paying a corporate lawyer this massive retainer just to draft standard vendor agreements.
The user simply types their parameters into plain English.
Yeah, and the AI understands the context, pulls the specific jurisdictional case law, and generates a watertight contract instantly.
Another standout from that fast-track list is the voice-driven mental health assistant.
Which we desperately need, given the severe shortage of human therapists globally.
Exactly.
Mm.
Imagine a conversational AI model trained on cognitive behavioral therapy frameworks. It's available 24 hours a day, and it scales infinitely to meet demand that humans simply cannot address.
Okay, I understand the utility of all these ideas. They're great. But I have to put myself in the shoes of the listener here and play devil's advocate for a second.
Go for it.
If the barrier to entry is truly zero, right, and literally anyone can spin up an AI tool in their basement over the weekend,
Yeah.
isn't the market just going to flood with absolute noise? I mean, how does any single business carve out $1 billion valuation when 10,000 other people are building the exact same legal contract generator?
It's a very fair question.
It feels like we're handing everyone on Earth a fully stocked master chef's kitchen. We're going to see a lot more people baking decent bread, sure. But that doesn't mean everyone gets to open a Michelin star restaurant.
That chef analogy highlights the central economic shift perfectly, actually. What's fascinating here is that the winners in this new era are not the companies that possess the best underlying AI models.
They aren't.
No, the AI model itself, the oven, the knives, the raw ingredients in your analogy, that is the commodity. Anyone can access a large language model via an API.
Right, the intelligence is abundant.
Exactly. The Michelin star, the billion-dollar valuation, is awarded to the founders who successfully embed that commodity AI into a highly specific, recurring workflow.
Okay, so the workflow is the actual product, not the intelligence.
Precisely. Let's look back at the legal contract generator.
Sure.
If you just build a website that spits out contracts, you have zero moat. None. A competitor can copy you by tomorrow afternoon.
Right.
But if you integrate your tool directly into the daily operating software of a mid-sized law firm, you change the game entirely.
Because the AI generates the initial contract, but then the human lawyers edit it.
Yes. They tweak clauses, they negotiate terms with opposing counsel.
And the AI is watching all of those edits.
Exactly. The AI is capturing every single keystroke of correction. It learns the specific negotiating style of that firm, the preferred risk tolerance of their clients, the specific case law precedents they favor.
Oh, wow. So every time a lawyer uses the tool, they're unknowingly training the system to be slightly better for the very next case.
That is the data flywheel. And it is the ultimate competitive moat.
So you start with a generic intelligence, but through that workflow integration, you accrue proprietary data.
Right. The more users you have, the better your system gets, which then attracts more users. A competitor trying to launch a copycat product next year might have the same baseline AI.
But they won't have the millions of micro adjustments your system has learned over the last 12 months.
Exactly. They can't replicate your accumulated context.
Okay, that makes a lot of sense. That clarifies the path to $1 billion. You take commodity intelligence, apply it to a high-friction problem, integrate it into a daily workflow, and let the data flywheel spin. But the source text doesn't stop at $1 billion. The whole mission of this document is the $1 trillion Solara.
Right, the big one.
And out of all the possibilities on that top 10 list, the author pinpoints one specific category as the most likely candidate to become the very first Solara.
Yeah, the author makes a highly rigorous case for an AI-powered marketing platform.
I have to admit, when I first read that in the notes, I was pretty skeptical.
Really? Why?
Well, I mean, we have synthetic biology, quantum computing, brain-computer interfaces on the horizon, and the first $1 trillion company is going to be in marketing. It just sounds almost mundane.
It does seem counterintuitive at first,
Mm-hmm.
but you have to strip away the word marketing and look at the underlying mechanics of what marketing actually is.
Okay, break that down for me.
Fundamentally, marketing is an information routing problem. It's the process of identifying demand, creating highly specific informational assets like text, images, or video,
Right.
and then distributing those assets to the exact right audience to influence behavior.
And information routing is literally the native language of artificial intelligence. It doesn't require robotic actuators to manipulate the physical world. It all happens perfectly in digital space.
Exactly. Furthermore, marketing is a universal commercial requirement. Every single entity that participates in the global economy must acquire customers.
From an independent graphic designer looking for freelance work to a multinational automotive manufacturer.
Right. The global advertising spend is already this ocean of capital exceeding $1 trillion annually.
But the text emphasizes that this current ocean of capital is wildly inefficient, right? And highly fragmented.
Oh, it's a mess. If you talk to anyone running a business today, their tech stack for growth is a total nightmare.
They're paying one vendor for email campaign software.
And they're using a totally separate platform to run ads on social media.
They have a completely different customer relationship management or CRM system to track their sales leads.
They hire freelance video editors using a separate platform, and then they try to make sense of all this disjointed data using yet another analytics dashboard.
The friction of moving data between those siloed platforms is just immense. So the author posits that the first Solara will be a unified, autonomous growth engine that collapses all of those tools into a single intelligence layer.
Yes, and the operational vision outlined in the text is wild.
How does it actually work for the user?
So a founder doesn't log in and start manually designing ad graphics. They simply provide the AI with their product specifications, their target demographic, and their monthly budget.
And the AI just takes over the entire pipeline.
The entire pipeline. It writes the ad copy. It uses generative models to create thousands of variations of video content. It automatically deploys these assets across every single social and search channel.
And then it runs multivariate testing, right? Monitoring which specific combination of video, text, and platform yields the lowest customer acquisition cost.
Exactly. It dynamically reallocates the budget in real time. It moves dollars away from underperforming ads and pours them into the winners 24 hours a day without any human intervention.
Here's where it gets really interesting to me. If I try to piece this together, if a platform actually achieves this level of autonomous execution, the financial implications are staggering.
Oh, they are.
We often think of companies like Salesforce as the ultimate enterprise software success story, but Salesforce is a CRM. It manages the data of customers you already have.
Right. It is a downstream tool.
Exactly. But this AI marketing platform sits upstream of Salesforce. It controls the faucet itself. Before a name ever appears in a CRM, that customer must be acquired.
And whoever controls the intelligence layer that drives customer acquisition.
You aren't just a software vendor anymore. You become the fundamental growth infrastructure for the entire global economy.
Precisely. And the valuation models for infrastructure are entirely different from consumer software. If a company becomes as vital to revenue generation as electricity is to a factory, the valuation ceiling essentially vanishes.
It's basically a license to print money, but the notes do highlight a massive logistical hurdle here.
Yeah, execution is everything.
Because identifying this opportunity on paper is easy, but actually building a trillion-dollar unified platform from scratch in a market that is this fragmented, where there are already thousands of entrenched software tools, it seems impossible.
It's incredibly daunting.
How does a company achieve this scale without spending 50 years fighting trench warfare against competitors?
Well, the author provides a specific strategic roadmap for this, and it centers on a concept called respectful mergers.
Respectful mergers.
Yes. The thesis is that you cannot build this Solara through organic growth alone, and you definitely cannot conquer the market through traditional hostile acquisitions.
I think we all intuitively understand why traditional acquisitions fail so frequently. I mean, we've seen it 100 times.
Oh, yeah. A large corporate conglomerate buys an agile, innovative startup.
They immediately fire the founding team to cut costs.
Right. They force all the remaining engineers to migrate their beautiful code onto the parent company's archaic legacy servers.
The company culture evaporates literally overnight, and the product dies a slow, painful death. It's basically a mechanism for value destruction.
Exactly. So, the concept of a respectful merger is an attempt to engineer the economics of scale without destroying the localized culture that created the value in the first place.
Okay, so what does that actually look like?
The model proposed in the text looks more like a decentralized federation.
So if I'm understanding the mechanics, a holding company identifies 20 highly specialized, successful AI marketing startups.
Right. One might have the absolute best sentiment analysis engine for reading customer reviews. Another has the most efficient video generation pipeline. Another specializes in optimizing logistics based on marketing demand.
And instead of a cash buyout where the founders exit and go buy an island, they do an equity swap. The founders roll their equity into the new parent federation.
Yes, and the critical distinction here is governance. The founders remain in control of their specific technological domains. They retain their internal engineering cultures and, most importantly, their operational speed.
I have to pause here because, look, this sounds great in a textbook.
Right.
But in practice, merging code bases and cap tables for 20 different companies, let alone the 100 companies the text projects over a decade, that almost always results in massive bureaucratic paralysis.
That's a valid concern.
How do you prevent this massive federation from becoming so top-heavy that nobody can get a simple feature update approved?
The safeguard against bureaucracy is the shared data architecture.
How so?
In a traditional merger, you spend years trying to force incompatible software systems to talk to each other. In this model, the companies remain modular, but they all plug into a central unified data lake.
Okay.
The integration isn't about forcing everyone to use the same HR software. It's about allowing the intelligence of one module to frictionlessly inform the intelligence of another.
Okay, walk me through how that data synergy actually works in practice between two merged startups. Let's make it concrete.
Let's take the company that specializes in email automation and merge it with a company that specializes in predictive supply chain analytics.
Okay, two very different functions.
Right. On their own, the email AI only knows how to optimize open rates based on subject lines. The supply chain AI only knows how long it takes a cargo ship to cross the Pacific.
Two completely isolated sets of intelligence.
Exactly. But when they plug into the Federation's shared data layer, they start communicating autonomously.
Oh, I see where this is going.
Yeah. The supply chain AI detects that a shipment of a specific winter jacket is delayed by 3 weeks due to say, port congestion.
It instantly sends a signal to the email marketing AI.
Right. And the email AI automatically halts all promotional campaigns for that specific jacket, preventing the company from spending advertising dollars on a product they cannot physically deliver.
And simultaneously, the email AI probably dynamically rewrites the upcoming newsletter to promote a different, fully stocked jacket instead.
Precisely. So the data synergy removes human middle management entirely. You don't need 5 departments having a 3-hour meeting to figure out how to handle the delayed shipment.
The system just recalibrates itself based on shared intelligence.
And as you scale this federation from 20 companies to 100 companies over a decade, that intelligence network compounds exponentially.
And the text actually provides a speculative timeline for this growth, right? Mapping the valuation milestones from startup to Solara.
It does. It's really interesting to see the math play out.
Let's lay out that timeline because I think it really grounds this theoretical model in actual market mechanics. The text projects that by year 4, this federation hits a $10 billion valuation.
Right. At this stage, the foundation is basically validated. The initial core of 20 startups has merged, the shared data lake is operational, and the cross-selling between their respective customer bases has driven massive revenue growth.
They have achieved decacorn status.
Yes.
Moving to year 6, the projection spikes to $50 billion. I'm looking at the reasoning here, and it's all about enterprise standardization.
This is the tipping point where large multinational corporations realize they can no longer maintain their own patchwork of marketing software.
The cost of running disjointed systems just becomes a massive competitive disadvantage.
Exactly. So they begin ripping out their legacy tools and standardizing their entire global operations on this unified AI platform.
Then, by year 7, the valuation hits $100 billion. The text describes this as a fundamental psychological shift in the market.
Yeah, the platform ceases to be viewed as just marketing software. It is now recognized as the fundamental intelligence layer of commerce itself.
Because it is predicting global consumer demand so accurately that manufacturers are using the platform's marketing data to dictate their raw material purchases.
It's running the economy at that point.
And then we hit the steepest part of the curve. Between years 8 and 9, the valuation rockets from $300 billion to $700 billion.
A massive jump.
And this jump isn't just about getting more customers. The text ties this massive leap to a fundamental evolution in the technology itself. This is the transition to the AI to AI economy.
Yes, this represents the shift from artificial intelligence acting as a tool to artificial intelligence acting as an agent.
I really want to spend some time exploring this transition because it seems to be the linchpin for the entire Solara concept.
It absolutely is.
Most of us interact with AI as a tool today. Even the most advanced language models require a human prompt. You ask a question, it provides an answer, and then it stops. It waits for you.
Right. A tool is passive. A hammer does not build a house unless a human swings it.
Sure.
An AI agent, however, is active. An agent is a system that is given an overarching objective, and it possesses the autonomy to sense its environment, make decisions, execute actions, verify the results, and iterate until the objective is met.
Without further human intervention.
Exactly.
The text argues that this shift to agentic commerce fundamentally alters the foundation of capitalism. It introduces this concept of the personal economic agent for consumers.
Right.
So, putting you, the listener, in the center of this, think about the sheer amount of time you spend executing minor economic transactions. If your refrigerator breaks, you don't just magically get a new one.
No, it's a whole process.
You have to spend 3 hours reading reviews, comparing dimensions, hunting for discount codes across multiple websites, arranging delivery times, and entering your credit card information.
The cognitive load of modern commerce is immense.
Yeah.
We just accept it, but it's exhausting.
Right. The personal economic agent absorbs that friction. You simply instruct your agent, my refrigerator is broken, find a replacement that fits the exact dimensions of my kitchen cutout, prioritizes energy efficiency, and costs under $1,200. Have it delivered by Friday.
And the agent then autonomously navigates the web. It reads 10,000 product reviews in milliseconds.
It filters out the fake reviews using sentiment analysis.
It pings the APIs of 50 different retailers to check real-time inventory in your specific zip code. It finds the optimal model, and then this is the crazy part.
What?
It negotiates the price directly with the retailer's automated systems, completes the transaction using a secure token, and updates your calendar with a delivery window.
All while you're just drinking your coffee.
Exactly.
And this autonomy extends to the enterprise level as well, right? The text envisions business agent fleets.
Yes. A mid-sized company in the future might only employ 200 human beings for high-level strategy and creative direction, but they will deploy 10,000 specialized AI agents.
What are those agents doing?
Well, some agents are constantly scanning global commodity markets to hedge raw material prices. Other agents are monitoring localized weather patterns to adjust digital ad spend for umbrellas in specific zip codes.
If we connect this to the bigger picture, the text brings up a fascinating piece of economic theory here to explain why this changes everything. Ronald Coase's theory of transaction costs.
Oh yes, Ronald Coase. He was a Nobel laureate who asked a deceptively simple question. Why do corporations exist?
Right, which sounds like a weird question at first.
It does. But think about it. In a perfectly efficient free market, why doesn't everyone just act as an independent contractor, negotiating a new deal for every single task, every single day?
Okay, if I try to apply this to a real-world scenario, if I want to renovate my kitchen, I don't go out and independently source the lumber, negotiate an hourly rate with a framing carpenter, draft a separate contract with a plumber, and hire an electrician by the minute.
Why not?
Because the time and legal fees required to search for those people, vet their skills, and enforce those contracts, the transaction costs are way too high, so I hire a general contracting firm instead.
Exactly. The firm exists because it internalizes those costs.
Mhm.
They put the plumber and the carpenter on payroll under one roof because it's more efficient than negotiating open market contracts every single morning.
Okay, I get it. The boundary of a firm is determined by transaction costs. You hire employees when it is cheaper to coordinate tasks internally than to navigate the friction of the open market.
Right, but agentic AI drives market transaction costs down to near zero.
Because an AI agent can search a global database of freelance plumbers, instantly verify their licensing and past performance data, negotiate a digital smart contract, and release payment upon verifiable completion of the task.
All in a fraction of a second for a fraction of a penny.
Wow.
When coordination becomes free, the necessity for massive, bureaucratic, vertically integrated corporations just evaporates. You can have a tiny team of 3 humans orchestrating a global supply chain that rivals a modern Fortune 500 company simply by deploying fleets of specialized agents to interact with the open market dynamically.
And if agents are doing the buying and selling, the traditional advertising model is completely dead. I mean, if my personal economic agent is buying my refrigerator, a flashy billboard on the highway is irrelevant.
Totally irrelevant.
A clever Super Bowl commercial with a celebrity endorsement means absolutely nothing to an algorithm.
The metrics of persuasion shift entirely. You no longer market to human emotion. You market to machine logic.
So brands will have to optimize their offerings for API discovery.
Yes, they will compete on objective data points. Verified durability metrics, supply chain transparency, carbon footprint scores, and machine-readable reputation ledgers.
It's like applying the mechanics of high-frequency stock trading to everyday life. Wall Street algorithms trade millions of shares in milliseconds based on complex quantitative signals.
And we are moving toward a reality where that same high-frequency algorithmic trading model is applied to buying groceries, hiring graphic designers, and sourcing manufacturing components.
The author describes this as the global marketplace without sleep. The economy just detaches from the biological constraints of human fatigue. Commerce becomes continuous, perpetual, and incredibly liquid.
And this perpetual economic engine is what drives the valuation of our hypothetical AI marketing platform to that $1 trillion mark by year 10.
But as massive as agentic commerce is, the text makes it very clear that artificial intelligence on its own cannot birth 1,000 Solaras.
No, AI is just the catalyst. To understand the true scale of this document, we really have to zoom out and look at the broader landscape of technological convergence.
Right. The author contextualizes AI by comparing it to historical general-purpose technologies: fire, agriculture, writing, electricity, and the internet.
And the distinction here is super important. Fire didn't just allow early humans to stay warm, it allowed us to cook meat, which fundamentally altered our digestion, freeing up biological energy that led to the evolutionary expansion of the human brain.
Electricity didn't just give us light, it externalized physical power, leading to the Industrial Revolution. The internet externalized human connectivity.
And artificial intelligence externalizes and amplifies cognition. It is an engine for human thought.
But an engine is most powerful when it is connected to a transmission and a chassis. The core thesis of the book is that this cognitive engine is currently colliding with 11 other exponential technologies simultaneously.
This is where the scope of the text gets almost dizzying. We aren't just managing the AI revolution. We are simultaneously managing revolutions in advanced robotics, synthetic biology, gene editing, brain-computer interfaces, quantum computing.
Fusion energy, advanced batteries, space infrastructure, extended reality, and nanotechnology.
Right. The historical precedent for this simply does not exist. We have never experienced multiple civilization-scale technological shifts maturing in the same decade.
And the key to understanding how this creates $1,000 trillion companies lies in the mathematics of convergence. Let's break down that math, because when I first read it, my brain defaulted to addition.
Oh, most people's do.
I thought, okay, we have AI, plus we have better batteries, plus we have some new robotics. But the text insists innovation is combinatorial. It's multiplicative.
Think of it as a series of interlocking, self-reinforcing feedback loops. Let's map one out. Artificial intelligence is increasingly being used to design quantum algorithms.
Okay.
Quantum computers operate fundamentally differently than classical computers. They use quantum bits, or qubits, which can exist in multiple states simultaneously, allowing them to solve incredibly complex probability problems.
So qubits are notoriously unstable, right? They
Yeah.
require near absolute zero temperatures, and the slightest environmental noise causes them to lose coherence.
Exactly, which has been the primary bottleneck for years. But advanced AI can predict and correct those quantum errors in real time, stabilizing the system.
Oh, I see.
So AI accelerates the realization of stable quantum computing.
Huh.
And once you have a functioning quantum computer, you possess the ability to perfectly simulate molecular structures and chemical reactions at the atomic level without having to run physical experiments.
Which radically accelerates nanotechnology and material science.
Yes. You can digitally discover novel alloys and metamaterials that humans would never have found through trial and error.
And some of these new materials might be the exact high-temperature superconductors required to contain the plasma in a fusion energy reactor.
Exactly. And once you crack fusion energy, you have effectively solved the global energy scarcity problem. You have virtually limitless, clean baseload power.
Which you can then use to power vastly larger, more energy-hungry AI data centers.
Which in turn train models that are orders of magnitude smarter than what we have today, starting the entire loop over again, but exponentially faster.
The compounding effect is just massive. So how does this combinatorial math actually manifest in the real world to create new Solaras?
Well, the text provides several concrete examples. Let's look at the convergence of AI and advanced robotics.
Okay, let's do it.
For the last 50 years, industrial robots were essentially blind, dumb machines. If you bolted a robotic arm to a factory floor, it could weld a car door perfectly, but only if the door was presented in the exact same millimeter of space every single time.
If a bolt was dropped or the lighting changed slightly, the whole system failed. They possess no spatial adaptability.
Right. But when you integrate advanced AI, specifically spatial intelligence and computer vision, into robotic hardware, you get autonomous physical labor.
The robot actually understands its context.
Yes. The text describes humanoid and quadrupedal robots that can walk onto an unpredictable, messy construction site, read the architectural blueprints, identify the physical materials scattered on the ground, and collaboratively frame a house.
That's incredible. Or consider agriculture. Instead of blindly spraying an entire field with pesticides, a fleet of robotic systems can navigate the uneven terrain, use computer vision to identify individual weeds, target them with a microdose of herbicide,
and then gently pick the ripe crops without bruising them. You were talking about the automation of the physical world.
construction, agriculture, logistics, mining. These are foundational pillars of the global economy, all of which are bottlenecked by human labor shortages and physical limitations.
A company that provides the robotic infrastructure for global agriculture easily scales into a Solara.
The text also heavily emphasizes the convergence of AI and synthetic biology.
This convergence represents the transition from viewing biology as a mysterious, unpredictable science to viewing it as an engineering discipline.
Synthetic biology treats living cells like hardware and DNA as the software code that runs on it. If I'm following the logic here, historically, if we wanted to discover a new drug, scientists had to go out to a rainforest, swab a rare tree frog, culture the bacteria, and run years of trial and error to see if it produced an interesting antibiotic compound.
It was essentially blind discovery.
With AI, we move from discovery to deliberate design.
Artificial intelligence models, similar to large language models but trained on the genetic sequences of millions of organisms, can actually learn the grammar of life.
So an AI can theoretically design a custom DNA sequence from scratch.
Yes, that will instruct a yeast cell to produce a specific, complex pharmaceutical compound or secrete a novel, biodegradable plastic substitute.
The implications for that are astounding. Instead of drilling miles into the earth to extract petroleum to make plastics, we could program vats of bacteria to grow sustainable materials.
We could design microbes, specifically engineered to consume microplastics in ocean water.
The text argues that the ability to program reality at the molecular level will spawn multiple Solaras in medicine, manufacturing, and environmental remediation.
And by systematically multiplying these 12 exponential technologies together, the author populates a landscape of 1,000 specific startup concepts. This is the true breeding ground for the Solara century.
The text organizes these concepts into several massive, future-facing categories, right? It outlines synthetic human enhancement, dealing with cognitive co-pilots and neural integration.
It discusses longevity economies, which shift the medical paradigm from treating disease after it happens to proactive cellular rejuvenation and slowing the aging process itself.
It details autonomous cities, where urban infrastructure, traffic grids, power distribution, waste management is managed in real time by integrated AI systems.
There's also biological computing, exploring the use of synthetic DNA for high-density, long-term data storage.
And in the final chapter, the deep dive focuses on the 10 most promising future Solaras. These are the specific convergences the author believes are most primed for explosive growth.
Right. This raises an important question, though. How do entrepreneurs even begin to build these?
Well, putting you back in the driver's seat as the listener, imagine trying to architect a business plan for one of these. Let's examine a few of the top contenders. One that completely reframed my perspective is the concept of planetary climate restoration companies.
That one is a massive paradigm shift.
For decades, we have viewed climate change mitigation as an economic burden, a cost to be minimized, usually driven by government regulation or nonprofit philanthropy.
The author flips that narrative entirely. These proposed entities are not nonprofits relying on donations.
No, they are hyper-profitable, aggressive, technological powerhouses that productize planetary repair.
The mechanics are really fascinating. These companies leverage massive infusions of cheap energy, potentially from early fusion reactors or advanced orbital solar arrays, to power colossal direct air capture facilities, scrubbing millions of tons of carbon from the atmosphere.
They deploy autonomous fleets of submersibles to reseed ocean coral reefs and alter the alkalinity of localized seawater to absorb more carbon.
And they don't sell consumer products. Their product is a verifiable, stabilized global temperature.
They sell measurable environmental outcomes to consortiums of national governments and multinational insurance companies whose entire business models are threatened by climate instability.
Another standout Solara from the final chapter is built on the convergence of AI and brain-computer interfaces. The text calls them brain-AI knowledge networks.
The current state of BCI is primarily focused on medical restoration, right? Helping paralyzed individuals control a cursor on a screen using their motor cortex.
Right. But the extrapolation here is consumer-grade neural integration. We are talking about connecting human cognition directly to external artificial intelligence networks.
The bandwidth of human communication is currently incredibly narrow. If I have a complex mental model of a new technology, I have to compress that thought into words, speak them out loud, and hope your brain successfully decodes my language into a similar mental model.
It's a slow, lossy process.
Very lossy. A neural knowledge network fundamentally alters how humans learn and collaborate.
The text suggests a future where you don't spend 4 years slowly internalizing the syntax of a new programming language. You interface with the network and download the operational capability directly.
Or imagine a team of engineers designing a new aerospace engine. Instead of drawing blueprints, they link their cognitive workspaces, sharing spatial visualizations and mathematical models directly brain to brain, augmented by an AI that tests the physics of their thoughts in real time.
The company that owns the protocol and infrastructure for that neural network is an undisputed Solara.
Finally, we really must look at the orbital manufacturing platforms.
Yes, the cost of launching mass into low Earth orbit has plummeted over the last decade due to reusable rocket architecture.
But the text argues that the real economic value isn't just going to space, it's what you build once you get there.
Microgravity and the hard vacuum of space offer unique physical environments that are impossible to replicate on Earth.
Without gravity causing convection currents or heavy elements to settle, You can manufacture ultra-pure fiber optic cables that can transmit data exponentially faster than terrestrial cables.
You can grow flawless protein crystals for advanced pharmaceuticals. You can print complex human organs without needing biological scaffolding to prevent them from collapsing under their own weight.
The Solaras in this sector will establish automated manufacturing hubs in orbit, managed by robotics and AI, producing high-value, low-mass goods that are then shipped back down the gravity well to Earth.
So after traveling through this incredibly dense stack of source material, what does this all mean?
So what does this all mean for you, the listener, navigating your life and career today? We have covered immense ground.
We really have. We started by examining the total collapse of the traditional software startup model and the explosion of AI-driven unicorns.
We explored the mechanics of the first, likely Solara, an AI marketing platform that acts as the growth infrastructure for the global economy.
We unpacked the strategy of respectful mergers, detailing how decentralized federations can achieve massive scale through shared data architectures.
We dove into Ronald Coase and the economic shift toward agentic commerce, where AI agents autonomously negotiate the global marketplace.
And finally, we mapped the convergence of 12 exponential technologies that will spawn $1,000 trillion entities, from planetary climate repair to neural knowledge networks.
The narrative arc here is undeniable. The global economy is entering an era of radical compounding acceleration.
The ultimate takeaway from 1,000 Solaras in 10 years is that we are crossing the threshold into an age of unprecedented technological abundance.
For the vast majority of human history, progress was constrained by friction: the cost of labor, the scarcity of capital, the limitations of physical energy, and the boundaries of human cognition.
Those constraints are rapidly dissolving. The limiting factor of the future is no longer execution, it is imagination.
Exactly. Whether you are an entrepreneur designing a new business, an investor allocating capital, or simply a professional trying to stay relevant, understanding this concept of convergence is your ultimate competitive advantage.
The future does not arrive in a neat, linear sequence, one technology at a time. It arrives all at once, violently overlapping and cross-pollinating.
The entities that will dominate the next century are those that recognize how to stack these converging technologies to solve previously unsolvable problems.
Which leaves us with one final provocative thought to consider.
We began this deep dive by discussing how the sheer scale of $1 trillion Solara breaks our traditional measuring sticks. We are building toward a civilization that operates at a velocity and complexity that is almost incomprehensible to the human mind.
But if we're truly entering a world where autonomous AI agents seamlessly execute our commerce, where advanced robotics handle our physical labor, where synthetic biology cures our diseases, and where fusion energy provides limitless power,
what happens to the human drive for purpose?
it is the ultimate philosophical question of the Solara century. When the struggle for survival and the friction of economic necessity are fully absorbed by machines, the fundamental nature of human ambition must adapt.
In a world defined by ultimate abundance and ubiquitous machine intelligence, where you no longer have to work to survive, what will you choose to do with your time? Thank you for joining us on this custom-tailored deep dive. We'll catch you next time.